Hey everyone, and thank you for joining me for this talk on DevOps stage on the static analysis of infrastructure as code. Today we're going to be looking at some open source tools and some ways that you can add security scanning and prevention of security misconfigurations directly into your CI/CD pipeline to scan things like Terraform, CloudFormation, and serverless framework in order to bring security to where your developers are working, i.e. pull requests, CI/CD pipelines, and just generally enabling easier integration of security controls into those type of systems. My name is Matt Johnson. I'm a developer advocate for Bridgecrew. Bridgecrew's aim is to make security easier across the board and to kind of bridge that gap between security teams and developers in kind of the modern DevSecOps world. I will be available on the Slack channel right now throughout the session to ask any questions or start up a conversation on any of these topics. Find me at MetaHertz if you miss me in the session on Twitter or you're watching back later. And also if you're interested in all things kind of codified security and bringing all those security checks into kind of, the developer's day-to-day tools and ecosystem, we've got a codified security channel on Slack at slack.bridgecrew.io where we talk and discuss kind of improvements and features and all things infrastructure as code security. So come and join us there if this interests you. I am a contributor to a lot of our Bridgecrew open source software, and also in my spare time I just have a general interest in kind of all things IoT security, Kubernetes at the edge, and other fun technical things. But anyway, let's get straight into it. So that was the intro, short and sweet. We're going to cover a bit of context first. We're going to cover kind of why infrastructure as code security. Why does it matter? What are the challenges we're seeing in the industry as people kind of embrace infrastructure as code and DevOps, and just kind of set the context for this whole conversation. Then we're going to look at some ways of kind of solving infrastructure as code and cloud security issues. Kind of what does static security scanning versus runtime security scanning mean, and look at some of the open source tools on both sides that can be used to enable better security posture. Then we're going to introduce Checkup. We're going to do a couple of demos with this open source tool and show you what it can do. And then we're also going to look at what we found with kind of the ecosystem and the open source community as a whole in terms of infrastructure as code and kind of security. So let's jump straight into it. So why infrastructure as code security in the first place? I think it's very clear that over the past few years, when we see things like, DevOps, when we see, engineers being expected to kind of build and maintain their own infrastructure for their own projects, that, the cloud is being codified. Anyone that's ever tried to use Amazon or Azure or, Google Cloud, pick your favorite. Anyone that's tried to use that without codifying the infrastructure some way, is not going to get very far. If you're using any of those cloud providers for anything serious, you're not going to be using the UI. You're going to be using something like Terraform. You're going to be using something like CloudFormation. Whatever tool, whatever infrastructure as code tool you're using, even if it's kind of your own hand-grown scripts against the APIs, you're definitely not going to be manually maintaining production infrastructure at any kind of scale using the UI. So as infrastructure as code is becoming, as the cloud is becoming codified, as we see infrastructure as code becoming best practice, because, you can commit that to source control, you can version, you can see what your infrastructure looked like at a given point of time. But it does add an extra layer of complexity, especially considering that engineering teams are having to effectively take on, in the cloud, this infrastructure as code set up, this infrastructure as code tooling, whereas maybe historically there would have been an infrastructure team that kind of provides all those resources, and the developers could just concentrate on their application code. So it's adding complexity, and with that complexity comes risk, because historically security has been a very specialist topic, and security teams have been available to kind of analyze and approve infrastructure changes. Now what we're seeing is with developers, expected to work faster with CI/CD, with kind of, multiple deployments to production a day in kind of DevOps movement, developers are expected to kind of cloud infrastructure their way around problems they face. So if a developer's having an issue, they might solve that by provisioning their own extra bucket or their own extra queue or their own extra cloud service to kind of move forward and carry on development of that feature or that project. So we're kind of moving away from that kind of security team approved infrastructure more towards decentralized responsibilities where engineering are responsible for the infrastructure and therefore the security of any infrastructure changes that they're making in this kind of new world, which is interesting because the security teams were focused very much on one goal. Their kind of performance incentives were based around the protection and the security of the infrastructure. They were threat orientated, risk management, kind of approving changes. That's very different to the day-to-day requirements of an engineering team that are looking to, get the next sprint out the door or get the feature or get the bug patched. So with the shift in responsibility come a very different style of working. Even security engineers, with the growth of the number of products and the number of APIs available on every cloud provider and the proprietary nature of most of those APIs across cloud providers. So especially if you're in a multi-cloud environment, security engineering generally doesn't remember off the top of their head all the defaults for all the products, all the security benchmarks, all the security standards for everything that may or may not be being used for a given product across public clouds. So why would we expect an engineer who their day job is kind of, adding features, fixing bugs, to also remember all of that? If you just look at the kind of list of security policies and standards there, no one is going to remember that day to day with all the required suggestions and remediations and secure defaults. Especially now we're working agile, we're working faster, and at the same time we do need something. We do need a way for engineers to kind of identify and correct and manage the kind of security best practices and potential security misconfigurations that writing infrastructure as code may open you up to. And part of the issue is that, if you're a security team and, you've historically run a security operations center, or, you've cared about breaches and default baseline security and, protecting an infrastructure or responding to events, you will have automated that process for your security team. Over the years, you will have found common tasks and you will have written scripts and you will have kind of have automated security operations center style dashboards where you can see security related information to help your team, respond quicker, patch quicker, respond to alerts, scan existing baselines for changes and things, all very much related to securing the infrastructures those teams were designed to protect and securing the business. But all those tools would have been built around the mode of working for a security team. They won't have been built for an engineering team. So the way those tools work is very, very different to the way an engineering team works. So, instead of a kind of SOC dashboard and graphs and charts and kind of alerts, developers work day to day in CI/CD and running tests and pull requests and, those kind of tools. So there are gaps between, existing security solutions and getting that information kind of in a least friction way in front of the developers, into the developers' eye line, in the tools they use every day, so that developers aren't expected to, suddenly learn a whole new suite of tools to basically, carry out their kind of new responsibilities of security. I mean, we could argue that the developers have always had a responsibility for security, but, with the way things are shifting to infrastructure as code, it is important that this doesn't become a this doesn't become a blocker. This doesn't become a time sink. Developers have spent a lot of time kind of moving towards DevOps and moving towards, enabling rapid progression of code through tests to production. We don't now want to kind of add steps which involve kind of maybe manual lookups in tools that were designed for a very different use case. So existing solutions leave gaps where it comes to security. A lot of the cloud providers do offer security tools, but as I kind of touched on, these differ from cloud to cloud, and everything from kind of IAM to security response tools are completely different for each cloud. So if you're in a multi-cloud and multi-infrastructure as code world, that's not really going to help you get a full picture. And again, suddenly means that a developer is having to check 2-3 different tools on 2-3 different sites with very different ways of working to kind of take on the security responsibility. And a lot of the kind of security scanning tools that developers may already have in their pipelines very much focus on kind of code security and kind of lack functionality for, an infrastructure focus. So obviously developers taking on this kind of infrastructure as code manifests and writing those infrastructures, we are going to need something to fill that gap. And, talking of kind of these gaps and talking of scanning for misconfigured, misconfigured infrastructure as code, it's worth having a look at where these kind of bad configurations come from. What is this? And usually, just like code, it's very possible that a misconfiguration in infrastructure as code, just like misconfiguration in any code base, it could come from a bad day or just a general mistake. But also, just like everyday kind of code that isn't infrastructure related, it's also very, very possible that it comes from a copy and paste template. There's the joke that, the essential copying and pasting from Stack Overflow, the fake O'Reilly book. I couldn't decide whether to go for this meme or this meme, to be honest, on this one, but I put them both in anyway. Stack Overflow gets a bad rep for this kind of thing, for people copying and pasting. But obviously, if you're trying to highlight to someone on the web, either in a GitHub sample or Stack Overflow or any of these locations, generally speaking, the code provided will be to kind of highlight the simplest way of solving a given problem. It won't be the most secure way of solving a given problem, because that would generally add a lot more code, a lot more supporting kind of, dependencies and information. And so that's just not the way kind of these things are communicated. It's not with, Python or Java or pick your Golang, pick your favorite language. And it's also not with infrastructure. So, we do accept that as a developer ecosystem, we do take samples off the web. Sometimes those samples make it through into production code bases, and it's the same with infrastructure as code. So it's very possible that a lot of the infrastructure as code that we're now writing in these DevOps teams is coming from web samples. So for example, the serverless framework has a great collection of ready-to-use examples. The Terraform registry is a huge repository of Terraform modules, which allow much easier creation of kind of complex solutions. So for example, you could either create, hundreds of objects yourself in AWS to create an AKS cluster, or you could use the kind of Amazon Kubernetes service module from the Terraform registry, give it a few specific customizations, and it will go and create those the rest of those Terraform objects for you. So there's huge use in these, but again, are these going to be secure defaults, or are these going to be defaults to make the user experience of, hey, click this, and click this to get started? There's always that usability versus security balance, especially with kind of trying to make things easy to, comprehend and to use from the internet. And we'll come back to this a little bit later. And I'm not for a second saying that these things are bad. I am not for a second saying, do not use infrastructure as code. Like, the value of infrastructure as code, as I kind of touched on, the value of being able to kind of source control and version and, have other engineers via pull requests kind of look at changes to the codified infrastructure via things like Terraform, via things like CloudFormation, is infinitely a more secure way of working. It's more auditable, it's more reversible than kind of the old school ways of manually running infrastructure. So definitely not a bad thing to be using infrastructure as code, just that there are things that need watching out for in terms of where your configurations are coming from, and that's what we're trying to do here. We're trying to make sure that we are taking account of those in the security posture, but in a developer friendly way. So when we kind of look at code snippets online, default configurations for all of these IEC frameworks, we see kind of things like logging, things like encryption at rest, disabled by default. We see things like HTTP turned on by default because it's easier than having to explain for a demo and getting something up and running how to do the whole self-signed certificate or do the key management server or all that kind of stuff. And we also see kind of things shipping by default with like vulnerable microservices. So all of these are kind of very infrastructure as code related. So as we said, the cloud's being codified. This kind of wraps up and summarizes why this context matters, why we should be looking at infrastructure as code in our CI/CD pipeline. The cloud's being codified. The existing solutions were not written for the developer audience. They were not written to kind of be integrated into the way developers works. And that means that kind of DevSecOps is becoming the new bottleneck. There's this skills gap between dev and sec. The tooling is different between dev and sec. Manual remediation is kind of resource intensive and just doesn't scale to the level of kind of deployments and the automation we're now trying to push for in development teams. So too much of the cloud security happens outside of CI/CD. And so that's what we need to do. We need to bring kind of infrastructure as code security practices, into the developers eye line. And there's a few different ways of doing this. I like to call this kind of solving and patching. And I'll explain why in a second. So first we'll talk about patching, which is kind of runtime scanning of infrastructure. So runtime scanning of infrastructure, and there's this great blog and this great open source project by Twilio called Sockless. And what they've basically done is used a load of Amazon primitives like lambdas, like step functions, to basically create automated remediations for any kind of your infrastructure security detection. So these might be any existing alerting, any existing logs that you're filtering for certain events. These might be something coming from Checkup, which we'll show you in a moment. But the idea being that if you have something that triggers in production, the Twilio Sockless blog allows you to kind of automate response to the kind of simpler or more regular or kind of common use cases. For example, this bucket's gone public, right? We should probably close that bucket from public until we absolutely know it needs to be open, because that might be a mistake, for example. That's a fairly simple thing to do. So definitely check out the Sockless project on GitHub. But this, what are those detection superpowers? Like where do these alerts come from to get remediated? And so in runtime detection, there's kind of two schools of thought. There's your event or activity based, where you are basically streaming log data, you are streaming output from systems, and you are putting it into something like Elasticsearch or something like for example, Elk Stack, and you are filtering and alerting based on seeing certain outputs that highlight something's not quite right, and you can alert and decide what to do based on those. So that's kind of event activity based, and we've had that since like pre-cloud. That's, even when you had like physical infrastructure, you'd still be spitting your logs out to something for central processing and kind of trends and, making sure your log volume, even if you weren't looking for things specific, you kind of know what your log volume should be for a given, load or a given output. So we're fairly familiar with that. And then the second type is API based, where the cloud has opened up all these APIs where previously we used to have to physically go and do things with metal and hardware and things. So suddenly we can actually get a lot more insights automatically from these APIs by just querying whether certain security settings are on or off for these managed services or for these kind of cloud provided services, rather than having to take kind of event streams and filter and manually do things. So we have kind of the event-based style, and then we have kind of the newer cloud toolings like Prowler, for example, which use these APIs to very rapidly identify, potential security concerns in a running environment. And so for those of you that aren't familiar with Prowler, the GitHub repo is there. Cloud Map is another great one for kind of mapping and visualizing connections between cloud resources and kind of how they all fit together. Prowler basically works by assuming a read-only role, so you can actually run Prowler and your kind of any remediations you want to do in a separate security account. And this read-only role will then allow Prowler to go and kind of scan all the relevant APIs and provide its recommendations either automatically or via output. So runtime using Prowler gets a great amount of information and is really, really useful. Because as we all know, whether you are using infrastructure as code or not right now, one thing is for sure, not many people have the luxury of greenfield. So Prowler is going to spot things that aren't in infrastructure as code. Prowler is going to spot things that, maybe someone has accidentally gone onto the wrong AWS account and manually created a resource and manually created some public access, or put in a security rule change to debug an issue and forgot to take it out and leave something exposed to the internet which shouldn't be. So runtime configuration checking with Prowler allows you to catch things that are live right now, that might be insecure right now. And on that topic, we have another open source project called AirIAM, which I recently did an OWASP talk for. So if you search for AirIAM OWASP DevSlop, you'll find this. I'll put the link in Slack when this goes live. And AirIAM is actually a runtime configuration tool designed to codify all of your IAM configuration. So it can suck down your AWS IAM configuration from a read-only AWS IAM API, and it will spit out a Terraform copy of your IAM configuration so that you can source control that, so that you can kind of diff that and detect drift in IAM, considering that IAM is basically the gatekeeper of which of these APIs the public or individual developers or individual pieces of your infrastructure can and cannot use. We wanted to be able to have a record of that. We wanted to be able to diff that. And we wanted to actually be able to manage that going forward with Terraform. But we appreciate that no one starts with a clean slate. So AirIAM allows you to basically take your current, maybe manually configured IAM and convert it very simply, automatically to Terraform, so that you can then carry on managing it with Terraform. So do check out the AirIAM workshop if you're interested in that. So back to Prowler. When we look at Prowler, it's great for things that are currently going on in your infrastructure. It will detect, hey, there's a new public bucket, there's this. Someone's manually gone into AWS maybe and made some changes. So, we like Prowler within Bridge Crew. It's a really useful runtime configuration tool. Now, the only issue with runtime is it's telling you what is already vulnerable. It's telling you this is happening in your live AWS account right now. What we really want is something that ties more into the thousands of steps the development team takes before you get to things running live in AWS. So we want to have things before code commits happen, before pull requests get approved, before the CI/CD pipeline takes something and makes it real in a cloud provider. And this is where static analysis comes in. So with static analysis, And we want to introduce a static analysis tool called Checkup, which is another open source tool by Bridge Crew like AirIAM. And the idea with static analysis is we can highlight security issues from infrastructure as code manifests. So we don't need to do, for example, a Terraform push or a serverless deploy in order to then highlight security issues with Prowler. What we can do with Checkoff is by analyzing that Terraform and knowing the security defaults of different Terraform and different serverless objects, for example. We also support CloudFormation. We can say, hey, actually, you're about to create a bucket in Terraform that you haven't restricted to no public access. You're about to create an EC2 VM in Terraform and you haven't encrypted the cloud init bootstrap volume. You're about to create a security group via Terraform and you're about to allow, this port access from the whole world, like 0000 or ::1 if you're really IPv6 friendly. And yes, those may be okay. You might be like, well, of course I want this public. This security group is attached to the ingress for my kind of public API or my public website, and that's fine. But in the same way, it's better to have those checks and kind of go, yeah, that is a security risk we accept, and it's meant to be there by default, rather than having no idea that someone's accidentally made a change in Terraform, which is, opening up your finance or your logging bucket or something that's meant to be encrypted to public read or public write, and potentially getting data loss or an easy backdoor for hackers. So Chekhov is designed to be at that step of the tooling. So it allows us to find security issues before we've actually made the infrastructure real. It's written in Python. A lot of security teams we find are very familiar with Python, even if they don't come from a traditionally development background, versus, say, C or Golang and things. So it's written in Python. It comes with 470 currently, and counting, built-in checks for CloudFormation, for Terraform, for serverless framework, for AWS, Azure, Google Cloud, resources in those, and also for kind of security defaults in Kubernetes manifests as well. We do accept community checks via pull request, and if you have a set of private checks, checks again can be written in the tool very simply in Python. I'll cover that in a moment. But you can also basically keep those to yourself and tell Checkoff to load those private checks if you don't want to submit them to the project itself. It's Apache 2 licensed, and it's a single binary with a few dependencies installed via pip, designed to be really, really easy to integrate into CI/CD. So the Checkup architecture looks like this. So it's kind of everything before, runtime, where things like Prowler will take over. So Checkup can either run as a pre-commit hook, because it's just a binary before you even make a commit from your local development workstation into Git. It can run as a CI/CD tool when you make a PR or just a regular commit as part of CI/CD in Git or in any of your source control systems. And the idea is it's designed to stop a deployment trigger pushing vulnerable code and making that vulnerable code real. And because we don't have to query any cloud APIs, because it's literally just looking at the static analysis of your infrastructure as code manifests, it's really quick. You get immediate feedback. So even if your developers were just, as I said, doing a pre-commit hook in Git, or initially just running Checkoff locally against their current Terraform or against their current CloudFormation or serverless, it gives you some really useful insights and links into how to maybe remediate or go about solving that problem. If you don't have any existing infrastructure as code, if you're thinking of going down the infrastructure as code route, you haven't really moved yet, we have a few projects to help kind of demonstrate static analysis. And we call these the GOAT projects. So we have some purposely vulnerable open source projects which give you a load of vulnerable Terraform infrastructure that we do not recommend actually deploying to any of your cloud accounts. So TerraGoat has purposely vulnerable infrastructure for AWS, Azure, and Google Cloud. And the idea being it kind of highlights the entire pipeline of how you would use checkoff, how you would use static infrastructure as code analysis to protect yourself from these kind of vulnerabilities making their way into your infrastructure. For those who use CloudFormation, we also have CFN Goat, which is exactly the same, but for CloudFormation infrastructure as code manifests instead of Terraform. And this one isn't by Bridge Crew, but there's been such a good amount of work, and it's just such a good resource. It's also worth checking out Kubernetes Goat, which covers the vulnerable infrastructure for a load of different Kubernetes security issues and concerns, and kind of, how you protect against them through learning how they are vulnerable and in what configuration they're vulnerable. So definitely worth checking that one out as well if you're interested in kind of the vulnerable by design tools. So installing Checkup is really, really simple. Like I said, we release it as a Python deployment via pip. We also have a brew tap for those on Mac, so you can just brew install Checkup. You can pip install Checkup, or indeed we keep a modern Docker image at Docker pull bridge crew Checkup latest, and then you can just pass your code into it with a -v volume mount, or however you prefer. So let's do a quick demo. As you can see, I've already installed Checkup here with pip. I'm currently on version 10541. And what I will do is just show I am currently in our TerraGoat repo. And as you can see in TerraGoat, we have a Terraform directory and then different vulnerable infrastructure for 3 different cloud providers. So if I go into AWS, it literally is as simple as running checkoff-d and then the directory you want to scan with checkoff. Now, by default, for CI/CD integration, we error out with a return code of 1 if there are any checks triggered, if there's any failed checks. And as you can see here, we have, a lot of best practices, and we highlight which Terraform file we found in that directory, which lines of code, show you the bit that triggered the rule, and you can see each of these is a different rule. We have guides that you can go to so that we can see, so that you can get some guidance on, what you would do about that, how to potentially remediate these issues. You can see we have a lot here for EKS. We have some IAM policies suggesting that IAM policies should be attached to groups or roles rather than individual users for simpler management and less likely to make mistakes and, tracking who has access to what. There should be no hard-coded access and secret keys in a Lambda environment, which is, not good. These are not real keys, by the way. They're just examples which will trigger the rule. So yeah, as you can see here, we have, understandably, because this is purposely vulnerable infrastructure, there are a lot of things flagged up when you run checkoff against TerraGoat or CloudFormation Goat. What we can do if we're, happy with a certain issue, we can basically skip certain checks if we know we're not interested in things, and also depending on your pipeline, we can also tell it to soft fail so it doesn't return 1 and kill the pipeline if you just want it for information only and you're not ready to kind of block on these things. We can also only scan for a certain framework, so if you know you only have Terraform and you don't want it going hunting for CloudFormation files or Kubernetes manifests, you can literally just say you want to just scan any Terraform related framework resources. And we can also output in very different formats to help integrate into your own tools or to integrate into CI/CD pipelines. So, by default CLI, but JSON, JUnit, XML, kind of GitHub security check style formats. And then if you want to load your own external checks from a directory or Git, if you're not contributing those checks back to the project, you can see you can do that. And you can also scan an individual file rather than a directory. So, yep, this is just for people following the slides afterwards. Oh yeah, and you can also do checkoff-list, which will show you all the built-in checks of the version of checkoff you're using. So as I see, we've got 471 checks by default in this particular version of checkoff. The checkoff Git repo dynamically updates these in the README as well, based on the latest binary. So if you don't want to download and run it, but you do want to see what checks are available, you can go through bridgecrew.io/checkoff and just look through the README in Git. So as I said, the whole point of this is to ease the load on developers. The idea being that with this tool, it is really easy to add checkoff into a CI/CD pipeline, or just have the developer, really simply run it as a pre-commit hook and get this information where it's needed. Now, we think the best way for collaboration with a development team, more than one, is obviously within the CI/CD pipeline. So that everyone can kind of see they are accepting risk, and everyone can see there's maybe some issues with the security of the infrastructure as code changes that are happening, rather than just the individual person contributing, via their own Git commit hooks. So the best way to do this would just be to integrate checkoff into CI/CD. And to do this really easily, we have a checkoff GitHub action. So if you're using GitHub, you can literally one kind of click and paste to make sure that you are scanning your infrastructure as code repos automatically as part of your GitHub pipeline. So use those free GitHub CPU cycles and kind of, make one really simple change to kind of give yourself visibility on any potential infrastructure as code issues. And as you can see, that will just do the regular kind of GitHub Actions annotation and highlight exactly what you saw when I ran this locally. You can see the check ID, and you can see some information and where that check has failed. I've already covered that we have multiple output formats. And so, yeah, it basically allows us to do, version controlled, peer reviewed through pull requests, and more to the point, automated within the software development lifecycle, which is super important for getting security and development closer together. Just very quickly before I wrap up, I said earlier that writing checks is very, very easy in Python. There should be a extra returned there. As you can see, that should be on another line. But other than that, you can see we have a load of kind of base classes that you can use. And with 470 checks, there will be plenty of examples to go through. Check out my video on bridgecrew.io YouTube for kind of setting up VS Code really quickly to write tests and kind of validate your changes. But yeah, this is very, very simply basically making sure we error if storage encrypted is not a valid key in this AWS DB instance resource. So any of these instances, we will check that this exists with this check and return a failed policy if not. So super easy to write your own checks. And then finally, to wrap up, just a couple of questions we always get with kind of Python, versus Python in checkoff versus things like OPA. And as I kind of covered earlier, we find that operations, security, kind of infrastructure engineers that might now be working on DevOps and DevSecOps teams, pretty much everyone's comfortable with Python. Coders can pick it up really easily. Engineers and security teams are generally already familiar. Whereas OPA is another opinionated thing to learn. So we've kind of taken this approach that if we're trying to do developer first security, it should be in kind of, developers' comfort zone. So, Python and CI/CD seemed like a really good fit. And so to wrap up, are we saying just use checkoff? No, they obviously fit kind of the pre-deploy and post-deploy scenarios. Our message is to, use both. They form a defense in-depth strategy for protecting yourself before you deploy vulnerable infrastructure, and then also looking at maybe drift and things that are out of your control after those things are, in the production lifecycle. And then finally, just quickly, it's worth mentioning that we've actually taken checkoff and scanned a lot of public repositories of kind of things like Terraform modules. And within this huge kind of community of Terraform modules, It's insane how much work has actually gone into these modules since COVID-19. So people are clearly very, very productive nowadays working from home. But we do see a large number of default modules. And again, it goes back to that security versus usability issue I was talking about earlier, where a lot of the time you want to show a simple example rather than a secure example for people getting used to these tools and these modules. So there are a lot of modules by default that don't meet the security recommendations in Checkov. And so we released a state of IAC security report that digs into a lot of these details. Because of this, we're actually going to release an update to Checkov in the coming weeks, which is going to automatically go and fetch any modules you're referencing in your Terraform code, download those modules, and give you a separate section output which shows you which parts of your Terraform code have Checkov checks failing, and also any dependent modules that you're currently bringing in as well. So I hope that was useful for you all. Please join us on Codified Security at slack.bridgecrew.io if you want to carry on the conversation, or ask questions in the DevOps stage Slack right now while we're all online, or go and check out the projects at checkov.io, airim.io, or TerraGo. Thanks very much.